Welcome, future statisticians, to another exciting lesson. We will be continuing our conversation about mean and median, the difference between them and when to use which one. The mean is non-resistant, is affected by extreme data. What that means is basically one high or low number will pull the mean towards it, but it will not aggressively affect the median. If you remember when we did the human box plot in class, and we brought in my special guest Yao Ming, how he really affected the average, but not so much on the median. The mean and median of symmetric data are close. They are equal if the data is exactly symmetric. So the more symmetric the data, the closer the mean and the median will be. So here's a little visualization of the Yao Ming question. Here's some, now I couldn't find basketball players, so the best thing I got here are swordsmen. And they are arranged from shortest to tallest. And basically, if I cancel out, I try to find the median of this data. There are 7 numbers, so there's going to be 3 on each side. 1, 2, 3. 1, 2, 3. This gentleman is going to be my median, or his height, rather. Now, it's probably roughly symmetric, so the average is going to be pretty close to the median in this case. However, if I add your friend and mine, Yao Ming, into the mix, he is significantly taller than even the tallest gentleman. So when I add these heights together, boom, 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 and divide by 8 now, that's going to really increase the mean. However, if I look at it, I've got 4 and 4, so the median is just going to jump from this gentleman's height to the average of these two now. Now this will be the median. So the median might go up maybe ½ an inch, but the average is probably going to go up a couple inches. So it really affects the average, this outlier, okay, or this extreme data, but doesn't really affect the median so much. So in this case, with skewed data or data with outliers, it's better to report back the median. It's not as it doesn't have as much of an effect. Okay, more with some measures of spread. Now this is a new term, standard deviation. I spoke about it in the last video. The symbol for it is S sub x. And basically what it does is it measures the spread about the mean. There's some fancy book definitions. I like to call it, how far are the numbers on average from the mean? So if the numbers are more spaced out, you're going to have a larger standard deviation. If they're closer together, you're going to have a smaller standard deviation. We have this other term called variance. Now variance is directly related to the standard deviation. It's just the standard deviation squared. So some quick algebra, basically to get from one to the other. So if you want the standard deviation and you have the variance, all you're going to do is take the square root of the variance, and that will give you the standard deviation. If you wanted the variance and you had the standard deviation, you're just going to take the standard deviation and square it. So it's a simple key in your calculator to go from one to the other. Now I'm going to show you how to calculate the standard deviation by hand. I'm going to give you this fancy formula, which is on your reference sheet. It's going to look bad, but fret not. Once we break it down, it's not too bad. So the standard deviation of x is the square root of the sum of each individual observation, the mean, x, each individual x minus the mean squared over n minus 1. Now I'm going to show you how to do this by hand first, walk you through each step. Like I said, when you break it down, it's really not too bad. So I have here a set of numbers, 90, 85, 80, 75, 70, and I find the average of those numbers, and it happens to be 80. So x bar, the average, is 80. So basically, like I said, it's the average of how far away these numbers are from the mean. So the mean is 80. I'm more or less finding out how far are each of these observations, on average, from the mean. So basically what I'm going to do is I'm going to subtract these two numbers. This is going to be each x. This is basically xi. I call each individual x. So we're going to subtract those two numbers. So I'm going to get negative 10. 85 minus 80 is, whoops, not negative 10. 90 minus 80 is 10. 85 minus 80 is 5. 0. 75 minus 80 is negative 5. And 70 minus 80 is negative 10. Now, over here, you see in the formula, you're squaring that right here. So basically, what I'm going to do is I'm going to square each one of those numbers and get 100. So this is each x minus the mean squared. 5 squared is 25, 0, 25, 100. All right? I'm going to take the sum of those numbers, and I'm going to get 250. All right? Now, to get the variance, basically, if you look at my formula over here, I'm taking the sum of all those. So I did this part here. I subtracted the differences. I squared each one. Then I added them all up. Then I'm going to divide by n minus 1. There's 5 numbers. So I'm going to divide by 4. All right? And get the variance of 62.5. Okay? Take the square root of that. All right? So I'm going to take the square root of 62.5. That is going to give me 7.91, which is my standard deviation. Okay? Now, again, if you needed to pause that at any time and go back and kind of try that, see where those came from, where the numbers came from. Now, I'm going to have you try one on your own. So take a second to pause the video and try that on your own. Okay, so there's the answer. Hopefully you got a standard deviation of 15.81 and a variance of 250. So notice a couple of things here. First off, if you look at these numbers, 100, 90, 80, 70, 60, those numbers are further apart on average from the mean of 80 than, say, this data set. These only went up by 5s. So you can see that the more spread out the numbers are, the larger the standard deviation. Okay, what standard deviation looks like graphically? Let's say that I have 3 data sets, class 1, class 2, class 3. And I want to determine which one has the largest, smallest, and medium standard deviation. Now, I can look at the box, right? I'm looking at these box plots. Remember, this is the interquartile range here. This is Q1, and this is Q3. So basically, it's real easy to determine from a box plot because the bigger the box, the more spread out the data is. The more distance between the median and Q3 or the median and Q1 covers, so the more spread out the numbers are. So I'm going to say that this here has the smallest standard deviation. The numbers are really, really close together. So this has a small standard deviation. This here, the top one, right, is going to have the middle standard deviation, all right? And then this graph here, that's really spread out, is going to have the largest standard deviation. Now, notice here that these two, the medians, are roughly the same. So it doesn't mean a bigger median or mean doesn't mean that it's automatically going to have a bigger standard deviation. It's all how spread out the numbers are. Now, this one here has a bigger median and a smaller standard deviation. So hopefully you can see that right there. And here is the actual statistics. Class 1 had a mean of 75 and a standard deviation of 12.63. That second one had a mean of 75. Like I said, the mean and the median are roughly the same. They're symmetric. But a larger standard deviation. The data is more spread out. And the third class, higher mean, right, 89.8 or median, and then a smaller standard deviation, not as spread out. Okay. A couple of things, also measuring spread, you've got Q1, median, and Q3. We spoke about those. Q1 is larger than 25% of the data. It's kind of the fourth mark. Median is larger than 50% of the data. That's the halfway. Q3 is larger than 75% of the data. That's 3/4 of the way. And again, the IQR is Q3 minus Q1. It's basically the distance of this box. Okay, properties of the standard deviation, some quick properties. S, or S sub x, measures the spread about the mean and should be used only when the mean is chosen as a measure of center. So it's paired with the mean. The standard deviation is 0 only when there is no spread. This happens when all data have the same value. Otherwise, the standard deviation is positive. As the observations become more spread out about their mean, S gets larger, and standard deviation, like the mean x bar, is not resistant. Strong skewness or a few outliers can make S very large, like the Yao Ming. Yao Ming's far away from the mean, so that's going to increase my standard deviation. So choosing center and spread. How do we choose between the median and IQR, or the mean and standard deviation? If the data is skewed one way or the other, you're going to use the median and IQR, because the median is resistant to those outliers. The Yao Ming didn't affect the median as much, so I would use that to describe that particular data set. So we would use the median. If the data is symmetric, you're going to use the mean x bar and standard deviation S. Hope you enjoyed this lesson.